confidence off. What's up with this? No. No, I'll have to borrow one. Do you mind if do you have two? Do you have one, Amanda?
No.
I'll borrow yours, thank you. We'll check together, yes. Okay. Did you try these?
Yes. I did.
You did? You read it. That makes me a little sad. Okay. Yeah, well, maybe her room is it. No, it doesn't matter. Right, A1. You know the exam's next week, don't you?
Yes.
Okay, just checking. Right, so the first one. A child throws a ball up in the air. So you have... You don't have one, Amanda?
I found so you can share.
Oh, okay, good. So the ball goes up and then it goes down. So this distance here is 1.23 meters, and the speed that they throw the ball up at is 15.6 meters per second. So the first question is the maximum height. Well, we know this one. UVATS. U 15.6, V0A minus 9.81, and I'll use V equals U. No, I'll use V squared equals U squared plus 2AS. And then this gives me S equals 12.4 meters. Is that the final answer? No, because we have to add 1.23. So the answer is 13.6 meters for the first part. This is part 1, or part A. And then part B is the time taken for the ball to hit the ground. So this is UVATS. The U is 15.6, the V we don't know, the A is minus 9.81, the T we don't know, and the S?
12.4.
Nope. No.
What?
I want the ball to go here now.
Minus 1.23.
Minus 1.23. So we have S equals UT plus a half AT squared. Oh. Minus 1.23 equals 15.6 T minus 4.905 T squared. So we can solve this for T easily. .26 seconds. I'm being lazy, so yes, I typed it in, but no. Sorry. You can use the formula, and you can check the answer on the calculator, but you can't be like me. You can't be lazy.
How to check it
on the calculator?
No, I mean square.
Oh yeah, well what I want to see in the exam is I want you to see this. T equals minus B you know, blah, 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 this thing. Yeah, I know, life is difficult. Life is difficult. That's number one.
But always through now.
I know, it's terrible.
If you
Mode.
do that, what?
Mode 53.
53. Okay.
To solve on the calculator, mode 53, you can solve this. Yeah? In this one here, the equation is 4.905 t squared minus 15.6t minus 1.23.
It's not minus, plus.
There's two answers. We only take the plus. Here?
No, I mean, if you change the equation, it's like minus 4.905.
Oh yeah, if you bring this to the right, that's fine. Yeah, if you want to do it that way. So, if you bring this over, it will be plus. So, Amanda, what you need to type on your calculator is minus 4.905 and then press equals, and then 15.6 and then press equals. What? What?
No. I got 3.0.
Hang on, let's do this together. Together! Mode 53 minus 4.905 equals 15.6 equal 1.23 equal. Huh? What? Why is it not minus 1 point what? Because I took this to the right. Because I need to make it equal 0.
Oh.
You get this? Continue. Great. A stone of mass 4.65 moving with that speed collides with a stationary stone of that mass and they move off together. So romantic with that speed. Right, so what happens? No, they don't move off together. So what happens is you have a stone here.
Not together?
No, they're not stuck together. They move off in the same direction, but they're not moving together.
Oh.
Yeah. So what happens here? You have the stone here, which is 4.65, and it's moving to the right with 3.26. And then there's another stone here, which is 2.41, and this is at rest. And then this hits into this, and what happens is they both move to the right, but not at the same speed. They're not moving together. We know the speed of this one is now 4.12. We don't know the speed of this one. I'll just call it v. That's what we want. Do you think, look at my picture, do you think the v will be bigger, smaller, or equal to this? Very good, it should be smaller, I think. Right, so let's check. We have M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. That's a point there. In fact, my V is negative, which is okay. So it means in my picture, it actually heads to the left. Now I have to read this carefully. So in the sentence, when they say this moves off in the same direction, they don't mean the same direction as this. They mean the same direction as it before it collides. They're saying that this moves in the same direction as this. So it's okay that my answer here is negative. It's moving left. So what happens in the picture is it comes along and then bounces off of it, like a snooker. Like this is the white and this is the red. So the white comes along and hits it, and then this starts moving and this one goes backwards then. Although I feel like maybe there's a mistake. Let me double check. Yes, I made a typing mistake. It will also be the same direction. Unless I made two typing mistakes. One more time. 4.65 times 3.26 minus 2.41 times 4.12 divided by 4.65. It is all the same direction. We're happy. V equals 1.12. That's better. The next part is how much kinetic energy is lost. So we'll calculate the kinetic energy here. A half m v squared. So the kinetic energy here is 24.71 joules. And then the kinetic energy here, a half m v squared plus a half m v squared. So in this picture it's 23.37 joules. So how much kinetic energy was lost? Not much. 1.34 joules. Yeah? Continue? Continue? Yeah? A3. A brass weight of mass half a kilogram and of temperature 100 is put into a copper can of mass 0.35, a mix of ice and water. What is the final temperature? Okay, so we'll draw this picture. So you have your water and you have your ice, and then inside of it you put inside the hot brass. So there's three things in this story. The and there's also copper. My goodness, there's four things in this story. So you have the copper. They put it into the water, yeah, so that's me. We drop it in. Okay. So before we drop it in, what temperature is the ice at? And the water? And the copper? No, the copper. Zero. And what temperature is the brass at? Here is 100. And there's 4 things here. There's brass, water, ice, and copper. This is a little bit difficult, so you have to listen carefully. Do you have this picture?
No.
Okay. What loses energy? The brass. And everything else gains energy. So the energy which is lost by the brass equals the energy gained by the ice, the energy gained by the water, and the energy gained by the copper. Now we don't know the temperature at the very end of the story, but we'll just call the end temperature X, is what we have at the end. Is that okay so far? So how much energy does the brass lose? Well, the formula is M. I'll just write M, I'll check it in a minute. The M for the brass, the heat capacity for the brass, and then how much temperature has it lost? It starts at 100 and it finishes at X. 100 minus X. Mass of the brass, capacity of the brass. This is the MC delta temperature. So this part is okay. Yeah? Yeah. Now we'll look at the copper next, because the copper is easy. Does the copper gain or lose energy? It gains. It starts at 0 and finishes at X. So we have M for the copper, heat capacity for the copper, and then its temperature change? X minus 0. So just X minus 0, or just X. Yeah, so I'll just write X for short to save space. What happens to the water? It also gains. So that'll be M for the water, heat capacity for the water, and then the temperature change from 0 to X? X. Yeah, X minus 0. Now, what happens to the ice? It gains energy. How does it gain energy first? What happens first? It changes into water. So first we have mass of the ice times the latent heat of the ice. But then what happens after it turns into water? It also increases. So again we have mass of the ice, capacity of water, times X. Okay. I'll write the numbers in, but I would like maybe you to read them out. So firstly, what's the mass of the brass? 0.5. Okay. The heat capacity of brass?
370.
Say again?
370.
370. 100 minus X. What's the mass of the copper?
0.35.
The heat capacity of the copper?
385.
Mass of the water?
0.25.
Heat capacity of the water? 4180, isn't it?
Yeah.
Times X. Going to run out of space. Plus mass of the ice?
0.1.
And then the latent heat of the ice?
134.
334. Next line, my goodness. Plus mass of the ice, which we said is 0.1. Then 4180. And then finally X. Right, so let's clean that up. 0.35 times 385 plus 0.25 times 4180 plus 4180. So on the right I get 1597.75x plus 33.4, and on the left I get 18500 minus 185x. Whew. Six point six equals 1782.75x. Please be a good answer. Not bad. So our final answer for x before I write it in. Should x be, for example, more than 100? No. So it should be less than 100. Should it be more or less than 0? More. So it should be between 0 and 100. Has to be between 0 and 100. And it is. So we're happy. X will equal 10.4 Celsius. And that's a lot of work for only 4 marks. I don't know who makes this. I forget his name.
John.
John.
I think it might be, actually. Okay, continue. Yep. A4 is about Young's modulus. You have a steel wire. Its length is 2.4 meters. Its diameter is 0.125 millimeters. There's a mass pulling down on it of 3.5 G. And Young's modulus for steel is 2.11 times 10 to the 11 pascals. And the first question is, what is the strain? So you have two formulas. You have 3 formulas for this lesson. I'll just write them down on the left before I continue. Young's modulus is stress over strain. Stress is force over area, and strain is extension over original length. These are the 3 formulas, which you should know. Right, so I want strain. So which formula should I use?
Half of the area first, and then y equals stress over
Strain is extension, which I don't know. Yeah. I think you're right. I think we first have to calculate stress. Yeah. And then we can get it, yeah. Stress is force over area, which will be 3.5 times 9.81 all over pi, or squared.
Shouldn't we?
Yeah? It's okay? Oh yeah, sorry, that's why it's not so. That's why. Yeah?
The area
Pi r squared.
is the
Circle. The area here
We only use the area
of the circle. It's called the cross section area is what we use. No?
Okay.
Okay? Which equals 0.2798 times 10 to the 10 pascals. And then we can use our formula. Young's modulus is stress over strain. So then strain is stress over Young's modulus. So our answer here, we divide this by and we get 0.01326. And then the last part is the extension. No unit for strain. The last part, strain equals extension over original length. So extension equals strain, which we have, times original length, which we have. So my answer multiplied by 2.4. And we get 3.18 centimeters.
What happens if there's no unit and you write a unit?
That it's wrong. I'll take 1 mark away.
Not half a mark.
Nope. 1 full mark.
X is 2.5.
2.4. Yeah. Okay, continue. Yeah. The next one looks easy. It's ideal gas law, A5. The volume we know. The temperature we know. The pressure we know. And they want the volume if they change the pressure and the temperature. So I'm just going to use this information here to get the N. PV equals N or T. So the N, how many moles, will be PV over RT. So for this one, it's P times V over R. 8.31. It's ideal gas law constant that you do with Lorraine also. So here we have 25 moles. Is that okay? So now in the next half of the story, we have, look, P now equals 1.78 times 10 to the 5, and T now equals 273.15 plus 25.5, 298. I'm not finished. They want the new volume if this is the new pressure and this is the new temperature. The number of moles stays the same, it's still 25 moles. P equals N or T over V. Wait, no, sorry, they want the V. If they, sorry. 0.3486 meters cubed. Now there's another way to do it, which I want to show you, which I think, Grace, I can see here is what you are going to do. Yeah. Can I continue? Yeah. So at the beginning of the story, the pressure is 1.01 times 10 to the hang on, pressure changes. No, we can't do it the other way, which you're going to do. So there was another way to do it, which is using this formula. PV is constant, or to say pressure is inversely proportional to volume. So you can see in this story what happens to the pressure. It increases. So if the pressure increases, what happens to the volume? It decreases. But this is only true if the temperature is constant. So for example, if the pressure got multiplied by 2, then the volume you divide by 2. But you can only use this rule if the temperature stays the same. And unfortunately in the story, the temperature starts at 0, but then changes to 25. So we could use this formula, but it won't be exactly right. But I want to use it to see how close it is, okay? So what's the pressure at the start? It's 1.01 times 10 to the 5. And then what's the pressure at the end? It's 1.78 times 10 to the 5. So did the pressure get bigger or smaller? It got bigger. We multiplied it by 1.76. So what should happen to the volume? No? Yeah, the volume, we should divide it by 1.76. And I get 0.3193 meters cubed. How close is that? Close, but it's not exactly right.
The reason it's not used that way.
I don't know. I don't think you can get full marks doing it this way. Yeah? Is that okay? Let's have a look at 6 now. You have 5 micro, 3 micro, 15 micro, 5 micro, 3 microfarads, and then 15 microfarads. What's the total capacitance here? How do we add them?
1 over C.
Yeah, 1 over C, 1 over 5, 1 over 3, 1 over 15. What did you get? Oh, 0.6 microfarads. No,
No?
you forgot to flip it.
Computer?
You have 3 over 5. It's 5 over 3. Five over 3 microfarads. Is that okay? That's okay, isn't it? And what's the next part, Sohi? What does it say?
C?
Yeah, the B part, yeah. Oh, I got it, thanks. The capacitor is connected to 40.5 volts and is discharged. Okay, so what you have in this part now is you connect the capacitor to a resistor. The resistor is 4.85 mega ohms. But before you do that, you charge up the capacitor by using a 40.5 volts. So at the very beginning, what will the voltage be? It'd be 40.5, and then what happens to the voltage as the capacitor discharges? Decreases until it becomes 0, yeah. Do you remember what the graph looks like? I sure hope so.
Yes, like this, and then it goes like this, right?
Oh no. Time in seconds, voltage in volts, starts at 40.5 and decreases.
Talking about the capacitor one.
This is the capacitor one.
What is it?
This is it. And it decreases, and we want the time till it gets 20 volts. So do you know the formula to use? V equals V0 e power minus, I think 1 over tau, isn't it? 1 over time constant multiplied t. Now, do we know the V? Yes. Do we know the V0? Yes. Do we know the time constant? No, but there's a formula for time constant. Do you remember it? Time constant, no, not that one. Time constant equals or C. Do we know or? And do we know C? Yes. So, that works out to be 80.83 T. It's this number multiplied by this number. This is the C and this is the OR. Right, that's all. "57 seconds is what I get when I solve this. Mm-hmm. 10 to the 6. And micro is 10 to the minus 6. Yeah. One more. We'll do A7 and then we'll finish with this morning. Oh, sorry. Yeah. You remember this? Resistance. Capacitance, yeah. A7. So we have our transformer. The voltage going in is 240 volts and the voltage coming out is 12 volts. The primary coil has 2,000 turns, and the secondary coil, we don't know, we'll call it N. So if you remember, it goes 240 over 12 equals 2,000 over N. Do you remember this formula? V1 over V2 equals N1 over N2. So 240 divided by 12 divided by 2,000. And then, yeah, so N equals 100. So there's 100 turns here. That's part A. Now part B. They tell us that these 12 volts here is connected to 1, 2, 3, 4 light bulbs. And the light bulbs are 20 watts. So the total here, 20, 40, 60, 80 watts in total. What is the resistance of the bulbs? Okay. Right, so if we look, maybe I'll just draw the picture out separately. Yeah. This one here is 20 watts, 20 watts, 20 watts, and 20 watts. So the total power is 80 watts. Yeah. Now, do you remember your triangle? You have VIR, and you have P equals IB as well. So we know the P, and we know the V as well. What's the voltage here? It's
Voltage?
yeah, the voltage. What did we say it was? It was 12 volts. Although it says in the story that it's oh yeah, it's 12 volts. Ah! Stop! Stop! I drew it the wrong way. The light bulbs are in parallel. I should have drawn it like this. 1, 2, 3, 4. There we go. Here is 12 volts. And these are 20 watts each. Okay, that's better. Okay, so P equals IB. So I equals P over V, which is 20 over 12, which is 1.67 amps. And in your triangle VIR, OR equals V over I, which equals 12 over 1.67, which equals 7.2 ohms. So we've worked out that these are 7.2 ohms each one. And they want the total. So how do you combine these resistance together? 1 over, yeah. So the total, 1 over OR, is 1 over 7.2 plus 1 over 7.2 plus 1 over 7.2 plus 1 over 7.2. We will. That's what I'll do. So OR equals 1.8 ohms. So in the first part here, I did it for each one, and then the bottom down here, this is the total.
It's only 2 months.
Yeah, I know. It's terrible. But there is another way to do it. And maybe it's a little quicker. I mean,
What's the lesson? P or R?
P over OR.
The left 1 over R. 1 over R.
Oh yeah, 1 over OR.
This is
Ah, there. It's okay.
yes.
Okay. There is another way to do it, which gives you the same answer. It's a little quicker. Can I show you? Yeah. So what you could do is put the 4 light bulbs together as one large light bulb. So if they're 20 watts each, how much is the total light bulb?
80.
80 watts. And what's the voltage? 12 volts. So you can have from your VI, your P equals IV, your I equals P over V, which will be 80 over 12, which is 6.67 amps. Yeah? And then from our triangle VIR, the OR equals V over I, which is 12 over 6.67, which is 1.8 ohms, which is good news for us. The same answer, which is good. Yeah? So you're right. Harim said this seems like a lot for 2 marks. I think he's right. I think the marking scheme would probably expect people to combine the 4 light bulbs as 1 light bulb in the beginning, like what I did in this slide. Right. Our next class is Thursday morning. Oh, sorry, C. Well, 1 mark. Hey, C. Look. Look. C is 1 mark, which means you should be able to do it very quickly. I can tell you the answer straight away. If the power on the output is 80 watts, then the power for the input must be 80 watts as well. In your transformer, because it's 4 light bulbs, 20, 40, 60, 80. Here, Sophie, this is what comes out. So, the power that goes in to the transformer must equal the power that comes out if it's 100% efficient. So if there's 80 watts coming out, there must be 80 watts going in. You're right. You can assume it's 100% efficient unless the question says it's not. Yes? Our next class is Thursday morning. Try to finish it for Thursday morning. I'll do some more in class. Here you go. Great. Thank you.